Hey everyone, how goes it? And welcome back to Computer Science 145. Today, we're going to discuss exceptions. Exceptions signal an exceptional occurrence during runtime. Now, these handle runtime errors by allowing the program to crash gracefully and keep executing. In Java, exceptions are objects, and these objects have an exception message. So in other words, what went wrong during runtime? We use the term throwing whenever an exception object is created. We also use the term handling when special code detects and deals with that exceptional occurrence. There's three major parts to exceptions. There's creating exceptions, throwing, in other words using, exceptions, and also handling exceptions. So let's take a look at each one of these parts. In Java, there are several predefined exceptions. Like the first one is exception, and that's the most general exception. You also have null pointer exception, index out of bounds exception, IO exceptions. And some of these you may have encountered before. Now, when creating exceptions, what we have to do is inherit from one of the predefined exceptions. As you can see in the syntax over here, we have public class. Because remember, exceptions are considered objects. So public class, the identifier, then followed by the reserved word extends, and then an exception. Now when we write our own exceptions, we only write the constructors. As you can see right here, after we have extended a predefined exception, we only write the constructors inside the body of this class. Now when we do write the constructors, it works the same way as writing constructors for any other inherited object. We need to make sure to use the reserved word super in order to construct the super class, or in this case, the super exception. As mentioned before, exceptions are considered objects, and those objects have a message, and that message is what went wrong. So it's not only important to call super in order to construct that instance of that exception, but you also should define the exception message, because that tells what went wrong during runtime. As we can see over here, we have an example where we have created a specific kind of exception called divide by zero exception. This extends the base exception, so the most general exception class, and then we have the two constructors. Our default constructor calls super, but then passes in the string attempted to divide by 0. Now this will set the exception message to that. So if someone was trying to divide by 0, this exception message would come up. Now similarly, we have the parameterized constructor which passes in this string message and then assigns the message here. The main idea is to keep in mind, if we are creating our own specific version of an exception, in Java, we need to inherit from one of the predefined exceptions. From there, we also need to set that exception message. Now, in order to use these exceptions, we have to throw them. Whenever a method could cause an exception, then the programmers who might be using this method need to be notified that they need to handle this kind of exception. The reserved word throws is used in the method signature to indicate the method could cause an exception. So if you notice over here, this is the same way that we have created a method in the past. So in the signature, we have the scope, the return type, the method ID, the parenthesis with the parameters, but then we add an extra part. We use the reserved word throws followed by a list of exceptions that this method could cause. This happens before the body of the method. Now each exception a method could cause is listed by their class identifier, and they are separated using a comma if a method could throw multiple types of exceptions. So in this example, we have public double evaluate, and then we have the parameters here. Now right before the method body, we have the word throws, followed by this divide by 0 exception that we saw earlier, a comma, and then a different kind of exception called unknown op exception. Now by writing this, any programmer that is going to call this method has to handle these two exceptions. They are signaled that this method could cause these types of runtime errors. Now, inside the method body that throws exceptions, there should be cases where that kind of exception happens. Whenever these exceptions happen, we use the reserved word throw to signal that this exception did happen. Now keep in mind, there is a difference. The reserved word throws is used in the method signature. The reserved word throw is used in the body of the method to throw that exception. Now after we use the word throw, we then follow that by constructing a new instance of that kind of exception. So if you notice the syntax, we use the word throw followed by new, followed by the exception constructor. So with our running example, we have throw, then we call new, followed by the constructor divide by 0 exception. Always remember that the reserved word new is then followed by a constructor in order to construct a new instance of that class, in other words, a new object inside of memory. Exceptions are objects, so what we do is throw a new instance of this divide by 0 exception whenever this happens. And finally, we need to be able to handle these exceptions when they happen. A method that throws exceptions must be handled inside of what's called a try-catch block. In the method signature, we defined that there could be runtime errors. In other words, we said that a method could throw different kinds of exceptions. When we do this, we signal to the programmer that this needs to be handled. In order to handle it, the method that could cause that exception must be written in the body of the try block. Otherwise, the method would cause a syntax error because it would be an unhandled exception. Now, the exception that needs to be handled must be declared in the arguments part of the catch block. Just like every other declaration, we have to use the type, in other words, the exception type, but then following it with an identifier. So the syntax for a try and a catch block is you simply have the word try and then the body of the try block. This is where you would put the method that throws an exception. Following that, we have the catch, which then has some arguments. Inside the arguments, what we do is declare a new exception type followed by an identifier. Because remember, once again, exceptions are objects. When we throw, we construct a new instance of that type of exception, which is caught right here. The exception is then handled in the body of the catch block. What I recommend is it's usually a good idea to print the exception message, either by using the method getMessage or the method printStackTrace. Now, using this running example, we have our try and our catch block. Remember, evaluate could throw a divide by 0 exception. This is why we catch an instance of this divide by 0 exception here. We use the identifier e, and then inside the body of this catch, we call the method printStackTrace. What printStackTrace does is it not only prints out the message that is inside the exception, but it also prints out what was on the call stack whenever this runtime error happened. This can be very useful in debugging these errors. If a method causes an exception in the try block, then the program immediately jumps to the corresponding catch. Now, after that exception has been handled, the program continues after the try-catch block. In addition to this, a try-catch block can only have one try, but it could have one or more catch blocks. Now, this is because methods could throw multiple kinds of exceptions, so we need to try to run this method and then catch whenever these exceptions happen. Multiple catch blocks need to be ordered in a very specific way. They need to be ordered from the most specific exception to the least specific exception, in other words, the most general. Now, if it's not written in this way, it could create a syntax error because you would introduce unreachable code. Now, with multiple catch blocks, the most appropriate catch block runs corresponding to the exception that was thrown. Once again, this is why it is important to order the catch blocks from the most specific one first to the least specific or the most general exception last. And we can see that in our syntax right here. So this is a try, but notice that we can have multiple catch blocks, where we need to order it from the most specific exception to the most general or the least specific exception. Now, with our running example, we know this method evaluate could throw a divide by zero exception, an unknown op exception, but notice we have the most general exception right here called exception. We needed to put this exception last because, as we know, divide by zero exception extends the type exception. This makes this a more specific version of that type of exception. If we were to put this catch block before these, then divide by zero, an unknown op, which we're going to assume also inherits from this type exception, would not be reachable. This can cause a syntax error. So then, if this method were to throw a divide by zero exception, it would jump to this catch block, handle it, and then jump outside of the try-catch blocks. If this were to throw the unknown op exception, it would jump to this catch block, handle it, and then jump out of the try-catch blocks. Now, if this method evaluate were to cause another kind of exception that wasn't divide by zero or unknown op, then it would be caught by the most general exception right here, handle it, and then jump out of the try-catch block. In addition to all of this, you can optionally add a finally block after a try-catch sequence. So after all of the catches, you can write the finally, and the finally block will execute whether or not an exception is thrown. So notice that the finally occurs right here, and you just write the code that's going to execute with or without exception. So with our running example, we just omitted the catches for space sake, but we run the code evaluate, and then, no matter what happens, we system.out.println this string result equals appended to the result here. Now let's see an example of exceptions. Now this is going to be related to some of the examples that we saw previously. Our problem today is we must create a simple calculator program. This program needs to keep track of a resulting value. It should perform the operations addition, subtraction, multiplication, and division. The user provides the input via the console, and that needs to follow the format operator space value. So in other words, the example would be plus space and then 3. Now this program must handle a variety of exceptions while keeping the program running. As you can see, we already have the project set up and ready to go. We also have some code written already because we primarily want to focus on exceptions. Before we get to that, let's step through what we have already written. So this is our class calculator right here. Then we have the instance variable result. This is the result that we're going to keep track of as we provide these operations. This is the result that we're going to keep track of as we perform those operations. We then have a constant here that's called precision, and this is going to come into play later when we get into division. We then have our main method, the entry point of the program, where we construct a new instance of this calculator, then we greet the user and tell the user how to use this program. So in other words, format each line with the operator, space, then a number. And for example, plus 3. We also indicate to the user in order to quit this program, they simply just have to enter the letter E. From there, the instance of this calculator, named calc, runs the method runCalculator, which we'll get to in a minute, and once this is done, we just tell the user goodbye. Now scrolling down a little ways, we're going to look at the method runCalculator. Inside of here, we create a new instance of scanner that's going to read from system.in, in other words, the console. It was mentioned in the program requirements that the user needs to utilize this program via the console, and this takes care of that part. We set this boolean done to false because this is going to keep looping the program until they enter E. Then we initially set our result to 0. From there, we initially print out the result plus the result. Now inside of this while loop, this is what is running the program. What we do then is we capture the next operator. Now, as the operators mentioned were addition, subtraction, multiplication, and division, we only need one character to represent that operator. This is why we call keyboard.next. The method keyboard.next is going to capture everything until the first instance of a space. As it was mentioned before, this is formatted operator space value. So what we do is we get the string, then we call char at 0, which is going to get the character at index 0, from this string. That way we can access that operator. Now, if this operator happened to be E, either lower or uppercase, then we set done to true, which is going to break out of our loop, and then we're going to say goodbye. But otherwise, what we do next, after we have captured that operator, we would then have a numeric value left over. This is why we then call keyboard.nextDouble in order to capture that numeric value and assign it to next number. Once we've done that, we need to then evaluate the operator and the number given our result. And after we've done that, we print out the result, the next operator, then the next number. So now what we need to do is create the method evaluate in order to take in this next operator, take in our result, and also this next number and apply it. So let's go ahead and start creating the method evaluate. So down here, we're now going to create public double, because we need to return that value, public double evaluate, and we need to ask ourselves, how do we evaluate this? Well, giving this character operator, we need two values. We'll say double number 1 and double number 2. Now we need to evaluate this operator given these two operands, but ultimately we need some sort of answer to return. So this is why I'm going to go ahead and define double answer, assign it to 0 initially, and I'm going to space down and then return answer, because we know this needs to return this type double, so we just set up this return value and then we return it at the end. Now, in order to do each one of these operations, I could easily create an if, else if, and else series of statements. However, I'm going to do this in a different way and rely on a switch statement. The switch statement works like this. You switch on some sort of controlling value. Now, this value could either be an integer, an enum, a character, or a string. Then I'm going to analyze each one of the cases. So for instance, case plus. So if this operator was equal to plus, then what I need to do is assign answer is equal to number 1 plus number 2, and then call break. Then we just have to do the exact same thing for the rest of the operators. Case minus. We assign answer is equal to number 1 minus number 2, break, case, multiplication. We just assign answer as number 1 times number 2, break, case, division. Now this is where we have to start being concerned with one of those runtime errors. We know we cannot divide a value by 0. This would be considered an exceptional case. Now, how do we know if that denominator, in other words, number 2, is 0? Now, what we could do is create an if statement, and then say if this number 2 is double equals to 0.0. But I'm going to do this in a slightly different way. It does not have to be exactly 0, it just has to be very close to 0 in order for this to throw an exception. So in other words, I'm going to use precision. So if this precision is less than this value, the denominator, and if the denominator is less than the positive precision. So now let's scroll up. As you can see here, the precision is a very, very small value. If our denominator is in between the negative precision and the positive precision, that means this is a very small value. In other words, this is close enough to 0 for us to consider it to be 0. As floating point values, in other words, double is short for a double precision floating point number, as they are imprecise, more often than not, it's not a good idea to just use the double equals. In a lot of cases, it's better to create a precision to see is it close enough to this very small value to be considered that value. So in other words, this number 2, if it's close enough to 0 in the negative and the positive, then we just consider it to be 0, and we cannot divide by 0. Now, this would be an exceptional case. Now, what we need to do is create a new instance of this type exception. Now, in Java, exceptions are objects, and we create classes to create instances that we call objects. So this means we need to go ahead and create a new class. And I'm going to call it the divide by 0 exception. Go ahead and put my name at the top. Now, whenever we're writing our own specific version of an exception, we need to extend a predefined exception. To keep this simple, we're going to extend the base exception. Now the divide by 0 is an exception. Inside of the body of the exception, all we write are the constructors. So we're going to concern ourselves with the default and parameterized constructor. Constructors work in the exact same way. Public divide by 0 exception, here's our default constructor. Now, just like before, when we're working with inheritance, it's important to construct this super class by using the reserved word super followed by the parenthesis in order to call the constructor. Now, in terms of an exception, the most important part of an exception is the exception message. So we're not just going to call the default constructor for exception, we're going to call the parameterized constructor and make sure we pass an appropriate message. So we're going to pass in the string dividing by 0 to indicate this exception was caused by trying to divide by 0. Now we just create the parameterized constructor by making sure we pass in a string message. And similarly, we call super and just pass this string message in order to make this work. So this is the first part of understanding exceptions. This is how we can create a specific version of an exception. To make sure that the programmers understand that this method could cause this exception, we go up to the method signature and we define that this method throws an instance of type divide by 0 exception. Now this is where it can happen. If this value was close enough to 0, then we need to throw a new instance of the divide by 0 exception. We put this in the method signature in order to warn other programmers that might be using this method that this method could in fact cause an exception. And in this case, we're worried about this divide by 0 exception. So when the denominator is too close to 0, then we throw a new instance of this divide by 0 exception. Yet, if it's not, then we just assign the answer is equal to the number 1 divided by the number 2. So now we have this method that could throw this divide by 0 exception, and it throws it whenever it happens. However, there's something that we may not have considered. If we're evaluating based on this operator, we said that the only operations that this method can do is addition, subtraction, multiplication, and division. But what if a user enters in an operator that's not handled? Within the switch, the default case is the else. So in other words, if it wasn't addition, subtraction, multiplication, or division, then this was wrong. This was an error. We can't do anything about this. And in fact, what we run into is another type of exception. We don't know this operator, so this operator is unknown. I would say what we need to do is create another exception for this unknown operator. So once again, in order to create our specific version of an exception, we're going to create a new class and call it the unknown op exception. Now we have to make sure that we extend a predefined exception, and in order to keep this simple, we're just going to extend the base type exception. And from there, we just create the constructors. Default constructor, where we're going to call super, and make sure that we set the exception message. Try to use an unknown operator. Then we create the parameterized constructor. and call super, passing this message to it. Now once again, we just created a more specific version of exception because in our program, we need to be able to handle this. It was only going to use addition, subtraction, multiplication, and division. So going back to our method evaluate, this can not only throw this divide by zero exception, but it can also throw an unknown operator exception. And where this happens is if it wasn't addition, subtraction, multiplication, or division, then we don't know what was trying to be done. So this is where we throw the new instance of this unknown operator exception. And what I'm going to do is actually use the parameterized constructor by appending the operator plus the string was used. So now we've effectively gone over the first parts. We've introduced how we can create new versions of exceptions, and we've also showed how we can use these exceptions, in other words, throw them. We need to warn other programmers that might be using this method that this method could cause a series of exceptions, divide by zero, and this unknown operator exception. Now, whenever these exceptions happen, in other words, if we are using division and this value, this denominator, is very close to zero, then what we do is throw a new instance of the divide by zero exception. If the user were to use some sort of operator that wasn't addition, subtraction, multiplication, or division, then we throw a new instance of this unknown operator exception. So now that we've written all of that, all we need to do is finally use this method. Scrolling up a little ways, we're going back inside of a run calculator method. So what we're going to do is now assign the result is equal to evaluate, the method that we just wrote. Now we're going to pass the next operator that we've captured up here. Then we're going to pass in the result. That's our first value because we're keeping track of this result. And then we pass in the value, the next number. And we should be good to go. Oh, wait a second. No, there's a syntax error right here on the method evaluate. Now this is because we have defined that this method could cause a divide by zero exception and an unknown operator exception. Whenever a method could cause a runtime error, could cause this type of exception, what we need to do is make sure that we place this method inside of a try-catch block in order to handle those exceptions. So entering down, I'm going to create a try block and put everything inside of here inside of this try block. So we're going to try to run this method, but we understand this method could cause exceptions. From there, we need to catch each one of those exceptions. I need to order these from the most specific exception to the least specific or most general exception. So I'm first going to catch the divide by zero exception. And I'm going to use the identifier E. So if this method throws a divide by zero exception, it's caught here and then assigns that new instance of the divide by zero exception here, and then I could call e.print stack trace. That way I can print out the exception, but also print out what was currently on the call stack. That way we can debug this later. However, that wasn't the only exception that evaluate could throw, because we also need to catch the unknown operator exception. We'll also call it E, and then we'll call e.print stack trace on this one too. Now these variables here only exist inside the body of the catch. This is why I can use this identifier and this identifier. And now that we've handled both the exceptions, divide by zero and unknown op exception, notice that there's no longer a syntax error on the method evaluate. Now I'm going to add something extra to this too. I'm next going to catch exception E. Now this is the most general exception that both divide by zero and the unknown op exception inherited from. And just like before, I'm going to call e.print stack trace in order to print out the stack trace and the error if something that we didn't account for happened. Now after all the catches, we're going to add the finally block, and this is going to run no matter what. Whether or not an exception happened up here, this is going to run. I'm first going to call keyboard.nextLine. This is one of those fix-ups that's been mentioned in previous lectures. Whenever we call the method nextDouble, nextInt, or nextBoolean, it's usually a good idea to follow it up with this in order to clear out the scanner. Now after that, we're just going to print out the string result equals and then append the result. That way we can see what's going on. So now that we have all of this, let's go ahead and test out our program. So we prompted the user, told the user how to use the program, so let's try out the example with +3. Well, there we go. Result plus 3 is 3. Let's do -2. Okay, looks good. Now let's try divide by 0. Notice this threw a divide by 0 exception with the message dividing by 0. It kept the result as 1, and it also printed out the stack trace where the error happened. Also notice that the program is still running, so I can now multiply this by 5, and there we go. Now let's try an operator we didn't account for. Let's try to mod this by 2. And notice this threw an unknown op exception where it passed the message mod was used. It kept the result being 5, but notice the program is still running. So I can add 2 to that, and we're still good. Now let's do something that we may not have accounted for. Let's say plus, plus. What's going to happen here? Well, this was an exception that we didn't originally account for, the input mismatch exception. The thing was, we called next in order to get the operator, and then we called nextDouble in order to get that value. However, there wasn't a double value. So then keyboard threw this exception when this happened. But notice that our program keeps running. It handled that exception, and we can keep going, so I can add 3, and we're still good. Now let's just go ahead and exit out of the program. In this lecture, we've talked about exceptions. Exceptions allow a program to gracefully crash during runtime, but keep going. We talked about how to create exceptions, how to use exceptions by throwing them, and also how to handle them. Now, being able to understand and handle exceptions become very important in future classes. Now, with all that being said, I'll see you next time.